So today we will see what's the deal with all this IK stuff. We have done some work with IK before, but we will see once again, we will see all of it and see it all in practice. So let's start first with foot IK, since we already done some hand IK and some look IK. So the first thing I'm going to do is, of course, I have a character over here, and I'm going to create a new script just so that we have RIK to write RIK code inside. So I'm going to name this IK handling, and I'm going to drop it into my character. Now, for the time being, I don't want these scripts, but since I'm taking the avatar from beneath my character, I'm going to leave them right now and use them later. Now, one thing we need to do first is our layers. Now I have these layers I don't really need right now. If we want to work on a layer, on an animator layer with IK, we have to have this IK path to be ticked, and if you have an avatar mask on a layer that has an avatar mask, you also need to not be calling the IK positions. Okay, this needs to be open. Now for the base layer automatically takes all the bones of the animation. Now let me open up my IK handle script. So first of all, we need to know, of course, is the animator, and we do it like this, as always. Now let's start first with some targets, and I'm going to give them public transform left IK target and public transform right IK target, and I also want to control the weight, so I'm going to also add a public float of, I'm going to name it IK weight, and I'm going to use the same float for both of the targets. Now everything that has to do with IK must go inside on animator IK. So the first thing we want to do is, of course, set the IK position weight, set the avatar IK goal, and I'm going to say left foot, and the float value will be the IK weight we just created. I'm going to copy paste this, and I'm going to change this to right foot, and I'm going to copy paste all of them, and instead of set IK position weight, I'm going to say set IK position, and the avatar IK goal will be the left foot, but over here we need to pass a vector 3, which in our case will be left IK target position for now. So I'm going to copy paste and for the right foot, and I'm going to add IK position. Let's initialize this to 1, and now back into Unity. I'm going to drop my IK target left and IK target right. I'm going to hit play, and I'm going to close the scripts for now, and you will see that we have our left foot is trying to reach the IK target, and as you see over here, it will go wherever we say it to go, wherever we place our IK target. Now, of course, when something like this happens, the knee is all wrong. So how we can fix that? We can say we can add two new transforms, and the same as we did the avatar IK goals, we can say set IK hint position weight and set IK hint position. So now, of course, this gives us an error because it takes, we have the avatar IK goal, but a hint is not an IK goal, is an avatar IK hint, and this doesn't have a left foot, but you can see that it has a left elbow, left knee, right elbow, and right knee. So it's the same for hands and feet. It's actually the same way you do it. So we will use the left knee. We will copy paste this over here and over here, and we will say not this, we want this right knee, and instead of the target position we are going to use the hint positions. So now, of course, we need to drop the hint positions. I have already made those. Hint left, hint right, and now when we hit play, you will see that even if I move my my legs over into a weird position, if I move the hints around, it will actually make the hint, the R knee, to rotate to fix his position. So with this you can fix a lot some weird issues. Okay, but as you can see, wherever I leave my IK target, it will always have the same rotation. So how can fix the rotation is simply by doing, instead of anim set IK position weight, we can do set IK rotation weight, and then set IK rotation. And of course this won't take the position, but it will take the rotation. Let's go back over here, and now you will see that our IK target will always have the rotation of the left foot, will always have the rotation of the IK target. Now, of course, this we'll have to automate all this stuff, and we want to automate it so that when we walk, it doesn't we don't have to manually move this around. So let's see how we can do that. First off, what we need to do is, of course, know when we don't want our animator to move, to use the IK. So we know that if we are walking on a walk, if you see, when he raises his feet from the ground, we don't want to use IK, we want to play the animation. But when he puts his feet down to the ground, then we want to enable the IK. And the way we do this, and the same way we already done this, is we will create two new floats inside our animator. I'm going to name one left foot and the other right foot. Okay, of course I've already made this. And then we will go into our animation and we will go into curves, and let me see how we can and you will see that for the left foot, you will see the value for the left foot, for the curve, is at 1 when we hit the ground. But as we are moving and as he has to raise his feet off the ground, then the moment he is out of his foot is not touching the ground, the curve is at 0 and it rises again when he has to hit again. So you can even go a lot more. This is a little bit exaggerated so that you can see what we are doing. So I'm going to give him even more air before he's touching the ground, and I'm going to add some more zero. I'm going to give him more time with the IK closed, and I'm going to give him, well, this will have to do. I'm going to make it only for the left foot so that we can decide, so that we can see the difference between giving him more air on the curve to have the IK enabled and the IK disabled. Now in my animations over here, only I have only added, of course, hit apply, I have only added curves into my idle state. So, and this idle state, this curve over here, if you open it, if you click the first one, will make your curve for all of its length have the one value. Okay, so that means when we are idle, when we are in the idle state, our left foot and the right foot parameter will always be at 1, so that means we have enabled foot IK. So with that in mind, keep in mind how you set up the curves play a big role on how it's going to show the IK. Okay, so let's jump back into our script and let's start doing some changes. Now, I don't want to use anymore the left IK and right IK targets, since we are going to be deciding the positions all with script. But I'm going to leave them since we are going to use them probably, even though the hand IK is pretty much the same for the hand. If I change here left hand, for instance, left foot, left, this will be the same. No, this will change, and here we'll say left elbow and the hint position, we need to pass the left elbow, and the rotation, of course, left hand and left hand. So now, instead of moving the left feet, it will change the left hand, and it will move him around. Okay, it's pretty much the same with the legs, but we're going to see some more examples that will save us work in our workflows. Okay, it's pretty much the same. So let's jump to our script. Now, for now, I'm going to change this back to where it was. Not left hand, left feet. I'm going to delete the hints, or maybe just comment them out, and I'm going to leave left foot. He doesn't have a lot of left foot, he only has one. So, and I'm going to also add this back to where it was. So we have all this. Let me bring it over here, and now let's add some variables. Now we want a vector 3 for the left foot position, and we also want a vector 3 for the right foot position, and we also need two quaternions for the left right rotation, the left foot rotation, and then a quaternion for the right foot rotation. Okay, so in our IK goals, let's change all this, and of course we also need two floats, and the first one will be left foot weight, and the other will be right foot weight. So let's change our weight for both for the position and the rotation to the appropriate ones. So with these two separate floats, it will change independently one another the weights. So now that we have our floats, of course we need to set them, to connect them with the parameter from inside the animator where we set our curve and all this stuff. And the way we do that is by simply using anim.getFloat, and we have the left foot, and for the right foot weight we want to take the right foot. Okay, so this opens up, this manipulates the weight with how the animator works and what animation plays and what curve we have on the animation we currently playing. Now we want to change the targets. Instead of the IK target, I'm going to pass the left position, and I'm going to pass the right position to a right foot. And for the rotation, I'm going to pass the new quaternions we made for our rotation. So now that we have set this up, we need a way to say how to know where to place our whip, our foot, and what rotation they will have. So I'm going to make a new transform, which I'm going to name left foot, and of course for the right foot I'm going to name right foot. And then for inside our update we will create two raycasts that make a raycast down to the ground and see what are we hitting. So of course we need a raycast hit variable, which we're going to say left hit, and of course we need a raycast hit variable which we're going to name right hit. Now we need to change to transform from local position to world position, the position of our left and right foot. So we create a vector 3 and we will call this left L pos, standing for left position, and then we will say left foot dot transform, not transform alone, transform point vector 3 dot 0, and this will make our transfer will transform the from local position to world position. And for the right foot we create a new, which we will call right position, and then we will take the right foot. So now we have our positions. We need of course to do our own raycast. We know for the left position will be the left position. We know we want to do the raycast downwards. We know we want to save it in left hit, and the distance, we can play a lot with the distance, but I'm going to use 1. And also, even though we are doing a raycast from the ground, you have to keep in mind that we might also hit our own collider. So when we do the raycast towards the ground, and if we hit something, that means we have a left foot position, so we do a hit left hit dot point, and then we have a position for RK goal. Now of course we need the rotation, and that will be left foot dot rotation, but we can't just do left hit dot normal, because this is a vector 3 of course. Okay, so we need a way to transform that into a quaternion. You can't do a quaternion dot Euler also, because it won't have the results you want. So what we need to do is take our quaternion and make it from pass the transfer dot up with our left hit dot normal, and we multiply this by transform dot rotation. Now if you don't understand this, no, don't worry, quaternions are a little bit difficult to understand. So we need the same for our right foot. Okay, pass the right position, pass the right hit, and we want the right F position and then the right F rotation, and instead of the left hit we need the right hit dot normal. And just like that, if we go back now, before we go back, we of course haven't set this up. So if we go now, we will take, if we hit play now, it will give us a non-null reference error. And that is because we haven't set this up. So the easy way to do that is, since we know we have a humanoid, we can say get bone transform animator, get your bone transform, and call the human body bones enumerator and say we want the left foot, and will be the same for the right foot, and we have set up our transforms. So let's save, let's go back, and if I hit play, you will see that he's actually lost his legs and we're probably getting errors. Now let's see what we forget. Now there are two problems over here. One is the Q none, and that we take this because we are one of our quaternions is returning 0, 0, 0. So anyway, the error is, the Q none is an error for about quaternions. So let's open up our first left foot. So this one, we get the error because we can't find the left foot over here, so that means something is wrong. Now let's click the pause and let's hit play again. So of course we get the error once again, but we take it on the other feet. So let's see where is the error and what did we forgot. Now probably it's because we are taking, it hasn't already set up the animator and there is no avatar, so I'm going to drop manually the avatar. Okay, and put it over here, and let's see if we get errors right now. And we still take an error. So let's comment out our rotation. Since it's a problem with the rotation, let's comment this out. So let's go back, and now we see that we have our character is moving his feet and he's sticking to the ground. When he's not moving, you can see that his rotation, the IK will always work. Now of course, in our character script over here, we are also using physics and we do changes from inside our scripts. So I'm going to close this and let's see over here. You see that he sticks to the ground whenever, because we're doing the raycast towards the floor. Okay. Now let's see. Let me see where the error for a quaternions were. So the problem with our rotation was, with our quaternions, was that even though we asked from our quaternions to go from one rotation to the other, but they were null, meaning that we didn't have any rotation upon those. And the way to fix that in simplest is we are already taking the left foot, then the left foot rotation will be the starting left foot rotation will be the left foot rotation, and for the right foot rotation will also be the right foot rotation. So let's go back, let's hit play, and for now I'm going to close the user input and the character movement, and I'm going to take a small cube I have over here. I'm going to bring it over here and I'm going to put it underneath our character, and you can see that it moves, but of course we can't see his feet. So let's add a little offset. Let's make it public, and we're going to say we need a public, and let's say offset Y, and then when we set our position, we will say we take the left position plus a new vector 3 0 offset Y 0, and then once again. Now let's go into a third person character. Let's set the offset the offset Y to something like 0.12, and let's hit play. Let's bring our cube once again, and as you have already seen, he moves. Now of course he is now going up because we have a collider over here. Let's make this a trigger so that he's still moving, because we are making a raycast also from our character movement script. So I'm going to close the user input, and that was probably a bad idea. So let's try this again. Let's bring this over here. Let's hit play, and then I'm going to make him a kinematic, and I'm going to say is a trigger, and I also want to close the user input as the character movement script for now. And when I bring my cube from beneath, you will see that he's not only placing his feet, he's also rotating them along the correct position. Now keep in mind, of course, that if it's something like this, you will probably need to play a different animation. Okay, IK is not for animating, it's not going to save you from animating stuff, although it's pretty capable, and the way you are using it could be pretty capable. You will also need animations to further improve the IK. So IK is mostly for correctional use and not for as something that you use independently from animations. So now that we see how it works when it's stationary, let's see how it works when we are moving around. So I'm going to focus my view on his feet so that we know what's happening, something like that, and I'll hit play and I'll move around. Now keep in mind that when we are running we don't have any floats, we don't manipulate the floats of our curves, of our animator. Let me so he doesn't influence the IK, but if I hit shift when we are walking, you will see that his left foot walks a little better, since we fixed that we have more we put some more control and we make it a little to be as not to be so much influenced by the IK, and the right foot we left it so that we can see the difference. And now if I'm going up a ramp, you will see that he positioned his feet also to the ramp. Now of course this is a lot influenced by the IK. Now if you play with the values and put them exactly as you want, then you will get a much better result than from what we already have over here. Okay. Now in AAA games mostly you will see that they are not so much dependent on the IK, and a lot of the times they just change the animation and just correctly place the feet so that doesn't look ugly. Now mostly when the character is sitting on when he's sitting idle, mostly then you will see that they change his position. They enable the IK for them. Let's see how he will walk over here, and you will see that now, even though we have the IK open, we also have a collider over here which doesn't let him pass over other options. So if I close it, you will see that he is moving and he places his feet. Of course, as I said, if you spend more time setting up the floats and where exactly you want them, you will have better result. Now sometimes you will see that the feet might even get some rotations that are not really that natural, so you can fix how much rotation you want the feet to be able to do. If you go and before applying the rotation over here, you can say take the left foot rotation, let's take the Y and make it 0. Now, of course, this is just an example, it's not to show you how you can do it, it's not something you should have without testing first. Okay, so let's go over here and you will see that whatever rotation we are having, he will return the Y, he will always be 0. The rotation will always be 0. Okay, if you do something like, let's say the Z or the X probably. and let's see how it will work. Let's make our trigger over here, and you will see that it has some better results already. The X is probably the up and down. Yes. So play with those values and see how it works for you. And that's basically it, the foot IK. Now remember, it's not a magical thing. It's not something that it's going to eliminate the need for your animations, but it's pretty much used as corrective animation. Now the thing that he puts his feet over there is because it hasn't already made the raycast to the ground. Okay, so that it fixes them on the next frame. You can initialize the first position so that it's not 0, 0, 0, and then he will have that position. And that's basically the foot IK. So let's see the body IK. So let's go back into Unity, into Visual Studio. Now let's add some public floats so that we don't have to come back into Visual Studio all the time. So the first float will be look IK weight. The second float will be body weight. The third will be head weight. The fourth will be eyes weight, and the last one will be clamp weight. Let's add a public transform so that we have somewhere to look at, and then what's this? We don't need this. And then we need to go into our on animator IK. Let's add it above all else, and then we will say anim set look at weight, and then we need to pass our floats. So look IK weight, the second will be body weight, the third will be our head weight, and the fourth will be our eyes weight, and finally the clamp weight. So if I said I need to set the look at position, and then the look at position, we know it will be the look position dot position. Save. Let's go back to Unity. I have an empty game object look position over here, so I need to drop it into my look position. Hit play, and right now you will see that he doesn't move, he doesn't do anything at all because we haven't set anything of the weight. Now let's try first with the head weight. I'm going to put 1. Okay, and now you will see that even if I move it right now, it doesn't move his head around, and that is because we might have set the head weight, but the look IK weight has to do with everything else. So if this is 0, all the other weights will also be 0. So if I set something like 0.5 over here, you will see that this is at 1, but the weight is 0.5. So that means he's not looking directly between the position, he's looking in the middle point between his the forward of the animation and the position he needs to look. Now if I change the head weight to 1, to 1, you will see that he is looking exactly to the position he needs to look. Now, of course, that means he can also look to some weird positions and recreate scenes from The Exorcist. Okay, he's pretty talented, as you can see. So one way to fix that is to use clamp weight. If I have my clamp weight to 1, then he will not break his limits. So he will, if it's in front of the position it can rotate, the head it can rotate, he will rotate normally. But if the position is way back, you will see that the longer it is on an axis that he cannot look, he will return to his normal position. And now, of course, this also works. Of course, you might not want to have something like 1, you might want to have something like 0.5. This is entirely up to you. Now let's set it to 1 and let's see the body weight. If I put the body weight to 1, he will of course rotate all of his body to look at the look position. Now normally what you normally see is done is probably something like 0.8, 0.7 or even 0.5, not the look IK, the body weight, 0.8 or 0.5. So his body drags around, his head is strictly looking at one position, and his body just drags along. So the eye weight, now of course for the eye weight to work, your rig must have bones for the eyes, which I don't know if this one has. It probably has from what I can see. So let's make the body weight to be actually let's make it 0. Let's make the head weight to be 0 and let's set the eye to be 1. And I don't know if you notice it, but he moved his eyes around. So if I move I will move the look position from over here, you will see that and you can see that he's looking pretty anxious. Oh no, they're on to me. Okay, so if you want to have now what you will normally see is done is have the eye weight to be 1, the head weight to be something like 0.9 and the body weight to be something like, let's say, 0.8, 0.7, and that is the look, how you do the look okay. Now of course let's make it so that we can use it in a game, in something more automatic, so that we don't have to move this around every time. So I'm going to set the weights once more. The head weight, let's make it 0.9 and the eye weights to be 9, and of course I want to clamp the weight. And now let's jump into our script and let's do it on update, doesn't matter. Now I want to make a raycast from the center of the screen of the camera, and the origin will be the camera.main.transform.position, and then the direction will be camera.main.transform.forward. Now of course you can also save the camera inside the transform so that you are not doing it all the time. Now I want to make a debug draw array so that we know what is happening. .main .transform .position, and this will be also the same, and I'm going to multiply this by something like 15 so that it's a long array. And now we will say we have array, so let's take a point upon array and we'll place the look position to that point. So let's give it the 15. Now let's maximize, let's see if everything is okay. Let's maximize and hit play. You will see that I can rotate. He's using the IK to rotate. Okay. Now because I have, or maybe let's just close the looking camera direction from my user input and see it once again. You will see that because I have my clamp weight, he is not always looking towards the correct. He's not always looking straight to the point. If I use my clamp weight to 0, you will see that in every positive direction I'm looking, he was always looking towards that direction. Now if I open it up, you will see that it moves like this. So that's pretty much it for the look position. Now let's see something we have already seen in our third person shooter series. So we have this weapon over here. Okay, so we have this weapon, but one way to put the weapon on his hand, let me rescale this a bit, is to take this weapon and drop it under his right hand. So, but let's not do that. Let's make it, let's go back into our scripts. We have our left IK target and we have a right IK target, and then let's copy paste all this and this, or actually let's copy paste all of this. Let's make a comment over here, and then let's change this to left hand, right hand, left hand, left hand, left hand, left hand, right hand, right hand, right hand, right hand, right hand. Now we don't want the offsets, so delete this, and the rotation we will change it. So the IK rotation, oops, I think we took a little bit more than we needed, so let's Ctrl Z. It's actually over here. So once again, left hand, right hand, and then let's just make it one universal, the IK weight, and then left hand, left hand, left hand, right hand, right hand, right hand, right hand. Now delete this, and then we'll say left IK target dot position, and then right IK target dot position, and then left IK target dot rotation, and then right IK target dot rotation. So let's go back. Now instead of having our IK stuff, RK targets just randomly over all over our world, let's take them and put them inside our weapon, reset the position, and if I hit play now of course I have it on maximize. Let's close the maximize. You will see that he's placing his hands on the weapon. Now of course he's also playing the wrong animation, so let's fix that. I'm going to drop an animation over here, or maybe yet I could drop it on a different layer, but anyway, let's just do it over here. So I'm going to drop an animation which I'm going to call aim. I'm going to set it as a default state, and now this animation is not aiming for. I'm going to close the weight, hit play, and let's see what it does. Now this animation of course is not for pistols, this is just for rifles, but because we have the IK, and if I enable it right now, you will see that it can also work as well for pistols. I'm going to set in the correct position the IK, the left hand IK and the right IK target, and it's probably somewhere around over here. Okay, the scale might be a little wrong. Okay, and this fixes the problem if you don't have animations for the pistol but you have for a rifle, or vice versa. Then you can have this, you can use it this way, and I can, if I move around this, and even if I want to move it to the front or to the back, or simply rotate that, I can also see that my IKs move and I can have more animations even though I don't have any new animations. I'm using the same one animation or I could use. Okay, so that's pretty much it for the IK. That's mostly what you have, what you can do with it. Of course you can do more stuff. Now let's see one last example with the curves so that we know that we have it set. So because I want to find the direction, because I don't want to search for directions, I'm going to create a new empty child over here, and I'm going to say direct pointer, I'm going to give it something that, so that we can watch it. And I'm going to bring this forward of my character. This is inside the third person character. Okay, so, and I want the right to look somewhere over there. It looks pretty good. So I'm just going to jump one last time inside our script, and I'm going to create a new vector 3. I'm going to say right hand position. I'm going to add a new float. I'm going to say right hand weight. And what else I need? I think we are done. Oh yeah, we need a public transform. Let's call it pointer. So inside update once again, let's do this beneath over here, and let's say we need a raycast hit, right hand, and then we need a physics dot raycast. We need the origin will be pointer dot position. The direction will be pointer dot right. We want to save it in right hand, and we want to the distance will be, let's make it something like 1, and then if we hit something from the right of the pointer, we will take the, maybe yet we don't even need this, but anyway, we will take the right IK target, the position of the right IK target, and then we will say the right IK target will have the right hand dot point. So we will place the right IK target to the position we just found. So this needs another one. Now I'm going to create a new, I'm going to say anim set bool raise, and then close this, and I'm going to write, and this of course needs to be true, and this will use, if it doesn't found this, will return false. Now I'm going to comment this out, and you will see why in a bit. Or maybe yet, let's just uncomment this, change this, and I think we are, the only thing left to do over here is just simply make a new float right hand weight equals anim get float right hand, and on the hand, let's put this underneath here so that we know what's happening. Right hand weight, and let's change this to right hand weight, and the rotation to also to have the right hand weight. Now let's close this. Now we need to pass some new stuff. Let's add a new layer, and let's call this right hand. Let's add a new avatar mask, and then let's only select the right hand the right hand, and the IK. Of course, you need to have IK pass, and let's call this probably it. Yes. So let's add an empty state over here, and then let's drop an animation. This animation is from the raw mockup data, and you can find it there. And let's make 2 transitions. So let's make this a boolean. Let's call it raise, and let's create a new float right hand. Now for the transition, we don't want any X time, and we want to raise his hand. He will see that he just simply raises his hand when it's true, and we want him to stop raising the hand is if it's false. Okay, now if I hit play, now of course the IK probably finds something else. The foot IK probably finds something else, or it doesn't find something, or it doesn't find the floor. That's why he has his position over there. Let's see if we missed something, and we didn't, so never mind. Let's try that again. Let's make this a trigger. And now he suddenly decided that he doesn't want to work. Float. Let's see if we have any errors, and yes, we have errors. And the error was that we don't have a pointer. We didn't assign the pointer, so it automatically skips a lot of stuff. So now that we have our pointer, even if we are moving towards, and the pointer, the raycast of the pointer probably finds something, and that's something. Let's see what he finds. Let's make a debug.log right hand dot collider dot name. So let's click play. You will see that now the pointer finds a wall around. But of course, even though he finds this, now we forgot some stuff. We forgot to set the weight of our layer. So let's see that again. So you will see that when he finds a pointer, he's raising his hand, and when the pointer doesn't find anything, he stops raising his hand. Now, even though he has found something, you will see that his hand is on the wrong position, and that is because we are passing the float. We are passing the weight over here is always at 0. So if I make this to be at 1, you will see that he's placing his hand on that position. Okay, so to automate that, we need once again to go into our animation and over here select the curve and say we want the curve to start when it starts to be at 0, and when he's around over here, which he has his hand raised, we'll make this to be 1 and the end to be 1 also. Hit apply, maximize on play, and if we move around, you will see that he's raising his hand, but something is not exactly as it should, and it's not exactly as it should because we forgot to give a name to our curve, so we need to rename this to right hand. So you see, when he is reaching a wall, he raises his hand and he closing, he's leaving it back. Okay, something similar you see in Uncharted and games like that. Now, of course, the rotation in the arcade is also wrong. So, in a similar way we did the rotation for the foot, you can also do the rotation for the right arcade target. So you can say right arcade target dot rotation equals quaternion dot from to rotation. Let's take all this. And it might not work, but let's try it anyway. Right hand transform dot rotation. Let's see. And that works a little bit better. Now, of course, you can put a little offset on the arcade. Let's go to a right hand plus new, not on the weight, right arcade target position plus new vector 3. Let's make the x to be let's make it 0.5 or not 0.3 3f 0 0. Let's see what that do. Hit play. And when he reaches, now it's to the opposite side. So let's make this, let's make this negative, and then hit play one last time, and simply you see that he positioned. Now, of course, the rotation needs some work, okay, but that's basically how you do stuff with the arcade without much trouble. So that was all for today. We see how we can do arcade for a foot. We see how we can do aim arcade and look arcade, and we see how we can finally make. Now, of course, this happens because we have the clamp weight. So if I put something like 0.5, 0.5, 0.5, and If I make this a trigger, you will also see that he's placing his feet. So as I was saying, we get familiar with the arcade system. That's pretty much how the arcade system works. I hope I didn't forget something, but I think I didn't. Now keep in mind that the arcade is not it's not something that you can use without animations, even though you can do a lot of stuff. Of course I'm moving around because I don't have a trigger. Now you need to have also a correct good character controller, otherwise the arcade, especially for the feet, it won't look, or even it might not even be noticeable. Okay, because as I said, because we are using physics to move our character and we have a lot of colliders, we also need to take into account that our collider reacts with the world, and we might position ourselves somewhere where our IK won't work. So that was it for today. Thanks for watching. Don't forget to like and subscribe. You can support me on patreon.com/csharpaccents, where with $5 or more you can get access to a folder where I drop all my scripts and add additional notes to them and a few guidelines. So thanks for watching once again, and I'll see you next time.